So today we will discuss the renewable energy theory firstly, and then we will do our lab. So in this class is about the types of solar collector. In previous class we studied that there is a solar collector and what is its main components and for which purpose the solar collector is used. In today class, we will study the two types of solar collectors. So first of that we go toward the types of solar collector. There is some environmental effect on solar radiation. The solar radiation received on the Earth's surface are non-uniform. Why they are non-uniform? Because there is some scattering of the radiation will be take place, refraction and reflection of the radiation will be take place due to the presence of the gaseous molecule in the dust particles. For example, this is the sun and this is the earth. The sun radiation came from the sun toward earth. So there are two types of radiation. Some of them can came directly to the earth, and some of them are first come to the clouds or any other gaseous molecule or dust particles and then scatter from these molecule toward the earth. So the radiation came directly from sun to earth is called beam radiation, and the radiation came from the sun toward the earth through some other before it came to other particle or cloud and then scattered toward the earth is called diffuse radiation. It means that the total radiation will be the sum of beam radiation and diffuse radiation, and this diffusion is take place due to the gaseous molecule and dust particle in the environment, that the sun rays are reflect from these particle, they are touched to these particle and scatter from these particle toward the earth. So the mathematical equation show that the total radiation, I mean the intensity of radiation, is equal to the beam radiation plus diffuse radiation. And what is the beam radiation? The solar radiation on the earth in line with source sun is called beam radiation. Either you can define that the beam radiation are those radiation which came from the sun toward the earth directly, and the diffuse radiation are those radiation received on the earth's surface after getting scattered because of atmosphere. So the because of atmosphere mean that there are some dust particles, some gaseous molecule, cloud. So the sun rays came toward the cloud and then scattered from the cloud toward earth is called diffuse radiation. And what is meant by useful radiation? So when we collect some radiation from the sun and this and the heat produce and the heat is transferred to the fluid flowing in the collector is called useful heat. The useful heat means the heat, this is gained by the fluid flowing in the solar collector. As you know that the solar collector there is some liquid flow in the solar riser tube, and the function of the tube is that and the function of the riser tube is that the heat come from the sun is transferred to the fluid flowing in the solar radiation, no, in the solar in the riser tube. The useful heat, for example, this is the solar collector, and this is its binder, and this is its riser tube. So the fluid will be flow. This is its inward flow, and this is its outward flow. So when the radiation came from here, this is either total radiation, mean some of them are diffuse and some of them are beam radiation, and these radiation will collect by the collector, and the heat of the radiation will be transferred to the fluid here. So the amount of the heat gained by this fluid is called useful heat. The amount of the heat received by this fluid is called the amount of the heat received by the riser tube. The fluid in the riser tube is called useful heat. And how you will calculate the this useful heat? So there will be efficiency of the collector, and the intensity of the total intensity of the radiation. And this total intensity will be the sum of beam radiation and diffuse radiation, and this is the effective area of a collector. The effective area of collector. So the product of these you can calculate the useful heat. For example, someone said that the efficiency of the solar collector is 75%, and the total beam radiation is a specific amount, and the area is some value. So then multiply these quantities with this efficiency is called useful heat. And you can also calculate through the second formula. For example, this is the riser tube. In the riser tube, this is the temperature of inward, and this is the temperature of outward. So the temperature in the outward must be greater than the temperature inward to the riser tube. The temperature of the fluid enter to the riser tube will be smaller than the temperature of the fluid out from the riser tube. So T naught minus Ti. And what is the Cp? Cp means the specific heat capacity of the fluid. That what is the specific heat capacity of the fluid? And M shows the constant, and it depends on sometime it depends on time. That unit time mean M is equal to 1, and by some other means so you will convert this into time.
Now, what is mean by CP?
Cp is the specific heat capacity. What is mean by specific heat capacity? That how much heat this is the property of the fluid, that it take the it take heat from the when you heat the fluid, so it will how much heat it will be take. So this is called specific heat. For example, they depend on the temperature like this, that the heat capacity of the uh, you see here, we will discuss here that a specific heat which is given by Cp is 0.0 T plus 0.2 kilojoule per kilojoule per kilogram per Kelvin. This is called specific heat capacity. Can by simple we mean that how much heat joule energy it will have when there is a 1 kilogram of fluid and the temperature is 1 Kelvin. For example, if the temperature is 1 Kelvin and the fluid flow in the riser tube is 1 kilogram, and how much joule energy it have now. So this is called the specific heat capacity. the the heat energy per unit kilogram and per unit temperature is called specific heat capacity. कि आपके साथ 1 किलोग्राम फ्लोवेट जब इसका टेम्परेचर 1 केल्विन हो तो ये कितना एनर्जी रखता है, इसको कहते हैं स्पेसिफिक हीट कैपेसिटी। समझ आ गया?
Yes, sir.
So by simple, this is the mathematical formula, that in this formula we will calculate the useful heat. So there are two formulas, one is this one and other is this one. So sometime if they give the specific heat capacity, so you can calculate through this formula. And if he say that radiation the radiation is how much amount, and the effective area mean the area of the collector and the efficiency, so you can use this one. So now you have able that find the useful heat, and you also know that there are two type of radiation, beam radiation and diffuse radiation, and what is mean by the effective area. So let's move toward the solar collectors. So there are two type of solar collector, one is non-focusing and one is focusing. There are two types of collector. Collector are either focusing and non-focusing. Non-focusing and the other is focusing. The non-focusing is, the example of non-focusing is platelet. The plate. In the example of focusing, there are two types. One is line focusing and the other is point focusing. Point focusing. So they are either non-focusing and either focusing. So in the case of non-focusing, we will discuss the plates, and they have already discussed in previous class. In which we studied that how many what is the components of the solar collector. So we discussed the plate capacitor, and there are other that which is focusing. So there's a line focusing and point focusing. What is mean by focusing? So by focusing we mean that the energy is focused to a specific a line, a specific point. And non-focusing mean that the radiation came from the sun, and some of radiation will be fall on the surface and it will collect. For example, this is the solar collector and this is the sun. So the radiation will be came from the sun toward either in this direction, either in this direction, either this, and some of the radiation will be fall on the surface. But there are not some any methods that they focus them in this surface. So some of the radiation will be fall on here, and when the radiation fall on the here, it will collect it. So this is the non-focusing type. When the temperature when there is a low temperature application, we can use this. What is mean by low temperature? For example, the fluid flow in the collector require low temperature, so you can use the platelet. And if they require high temperature, so you can't use the flat plate collector. and the efficiency is very low, 25% of theoretical efficiency. The the maximum temperature is 100%. That for example, if you want to heat the fluid up to 100 degrees C, so you can use this, and the concentration ratio is 1. By the concentration ratio we mean that for example, this is the area, and when some radiation fall on it, so they store mean they absorb it. So when the falling and absorbing are equal, so the ratio will be 1. If the falling are 100 radiation, and they absorb the 100, so the ratio will be 1. But when we focus it, so they will collect the more radiation in smaller area. So there are two types of focusing. Focusing radiation mean that they will focus the radiation in a specific area. So the focusing are force circulation require. So in it mean that what is mean by force circulation require? In the focusing type, we will provide some process, and this process will force the radiation to fall on a specific area. Here, the sun radiate the radiation, but it is there is no other method that force the sun radiation that fall on the this surface. But here we will provide some external requirement that force the radiation to fall on the specific area. For example, this is called line focusing. So this is the line focusing. Suppose this is the line, and we want to focus it, so we will use such half cylindrical type of reflectors. So the rays will be came here. For example, this is the sun. So the sun rays will be came here, and they will be reflect. Some of them will be fall directly, but some of them will be came here, and they will focus to this point. Some of them will be fall here, and they will be focus it. And similarly here, it means that all the radiation fall from this area will be focus back to focus on this riser tube. It means that we focus all the radiation at this line. Some radiation will be fall here, some here, but it means that at this line all the radiation will be focused. For example, in previous case, this is the sun, so some will be fall and some will be not focused toward this. But here we will do something. For example, in the case of solar steam turbine, we say that there are reflectors, and the sun rays fall on this area, either on this mirror, either in this mirror, either in this mirror. They focus all of them into this area. In this area there is a water, and they steam up, and we use the steam turbine. So similarly, here when the rays came from the sun, they will focus it on the line. So this is called line focusing, because they will be all the rays will be fall on this line, and it is behave like that when we were uh, And when we were student in primary portions, so we will use some mirrors, like mirrors of the lenses of the glasses, and we were doing that. This is the अब इस तरह सपोज करें कि ये आपके साथ क्या है, कोई एक स्पेसिफिक माच से या कोई कपड़ा वगैरह इधर पड़ा है, और हम इस तरह करते कि हमारे साथ एक लेंस होता था। हम ये जो बूढ़े होते थे इनकी जब ग्लासेस खराब
Yes,
होते
sir. Yes, sir.
हम उठाते थे, और हम क्या करते थे, ये सूरज के डायरेक्शन में रख देते थे। जब सूरज के डायरेक्शन में रख देते थे, कुछ टाइम के बाद ये आपके साथ इतना गर्म हो जाता था कि वो क्या हो जाता, वो जल जाता था। مونږ به ویل لکه ته په دې شیشه باندې دغه د ماچسو دا تیلې وسوځي، او کله به مې پسې کپړه چې ده نو ځینې کپړې ته به مې داسې وکړل، هغه مې پرې ډېره ګرمه کړله. دا پروسس هم چېرته کړي؟
Yes, sir. کړی مو دی ډېر.
نو دغه شانتې دلته موږ څه چل کوو، په دې लाइन باندې موږ دا څه کوو، फोकस کوو. हम क्या करते हैं, इस लाइन पर इसको फोकस करते हैं, दिस इज कॉल्ड लाइन फोकसिंग. सो इसमें क्या हो जाएगा, क्योंकि कुछ तो बाय डिफॉल्ट भी पढ़ते हैं, कुछ को हमने मजबूर कर दिया, इसका मतलब है इसका कंसंट्रेशन रेशो भी मैक्सिमम होगा, क्योंकि कुछ तो बाय डिफॉल्ट इसमें पढ़ती थी, ठीक है। सो जितनी भी पढ़ती थी वो इस पे इसको तो इंतजार करती थी, कुछ नहीं पढ़ती थी उसको भी हमने मजबूर कर दिया। इसका मतलब है हमने क्या किया, जो बाय डिफॉल्ट पढ़ती थी उससे बाय फोर्स इसके साथ हमने ऐड किया, तो इससे कंसंट्रेशन रेशो ज़्यादा हुई है। तो कहने का मतलब है कि पहले कंसंट्रेशन रेशो 1 था, अभी कंसंट्रेशन रेशो ज़्यादा होगा, क्योंकि हमने मैक्सिमम रेडिएशन को इधर कंसंट्रेट कर दिया। जो भी बाय डिफ़ॉल्ट पढ़ता था वो तो पढ़ता था, जो नहीं पढ़ता था उसको भी हमने फ़ोर्स किया। हमने कंसंट्रेशन रेशो क्या किया, ज़्यादा कर दिया। और इसकी वजह से क्या हो जाए, जब हमने कंसंट्रेशन रेशो ज़्यादा कर दिया, सो द फ्लूइड फ्लो हियर will have greater temperature. So it means that it is used for the high temperature application. It is used for the high temperature application. For example, so it is used for the medium temperature application. ठीक है, by high mean that it is high from the low, and it is medium in the case of a point collector, as the point collector will be focused just a point. It means that the temperature in the point collector will be high, and its efficiency is uh, 50% of theoretical, and it is called parabolic. This shape is known as parabola. You know that this shape is called parabolic shape. Either this shape, either this shape is called parabolic. So this is called the efficiency of parabolic is equal to 50% of theoretical, and the concentration ratio is 100. इसका कंसंट्रेशन रेशो का 100 का मतलब है कि हमने बहुत ज़्यादा क्या किया, बहुत ज़्यादा रेडिएशन को हमने इधर कंसंट्रेट कर दिया। वो तो कंसंट्रेशन रेशो 1 था, इधर कंसंट्रेशन रेशो क्या था, बहुत ज़्यादा हो गया। And this is called point focusing. What is mean by point focusing? When we focus all the radiation in only just one point. So, for suppose we want to focus all the radiation at that point, this is the specific point. In this case, we will use some reflectors like this. All the radiation came here will be focused toward just only one point. And you know that there are two types of mirror. One is called concave mirror and one is called convex mirror. So in the case of convex mirror, we say that all the radiation will be focus a specific point, and this is called principal focus. And the length from this point toward this point is called focal length. You may know this in your metric physics, but if you don't know, so you will study this in the your new course in coming semester, whose name is the optical fiber communication. So in optical fiber communication, we will prove some laws about the lens and about the m- mirror, and then we will use that what is mean by the cone, light cone. तो and we आप जानते हैं ना कि लाइट किस तरह फ्लो करती है, इस डायरेक्शन में, इस तरह जब ये लाइट सोर्स है ना तो लाइट इस तरह फ्लो होती है, इस तरह एक कोन क्रिएट करते हैं, इसका लाइट कोन। और आपके साथ जो ऑप्टिकल फाइबर है उस तरह फाइव होते हैं ना। सो फॉर एग्जाम्पल ये आपके साथ लाइट है तो इससे कुछ लाइट इस तरह ज़ाय होगा, तो आप क्या करें, इसके साइज को क्या करेंगे, रिड्यूस करेंगे। तो कैसे आप साइज को रिड्यूस करेंगे, इसके लिए कुछ टेक्निक्स होंगे। फिर आपके साथ ये कोन की साइज इतना है, फिर कोन की साइज इतनी हो जाएगी। सो ये कोन साइज फिर इससे आसानी से पास हो, दिस इज कॉल्ड कोन साइज रिडक्शन। ये ऑप्टिकल फाइबर में हम क्या करेंगे, पढ़ेंगे। So the high temperature application and its efficiency is 80% and its concentration ratio is much more high, 10,000. It means that all the radiation will be fixed in just one point. You see, you know that what is mean by concentration ratio? Mm, This area is very small, and the radiation are very large. It means that uh, the when this area is small and the radiation is came, mean concentration ratio will be high. देखो इधर डिवाइडर वैसे की स्माइल की इफेक्टिव एरिया चला सा स्माइली और रेडिएशन पे ढेर फाल की उन्हें बिया बसा सकेगी और ए पिछला बसा सकेगी सेवा की कंसंट्रेशन रेशियो बसा Simple concentration मतलब داري شي يو قال حالك يقول په concentration سوي شي ته ته ولا concentration وکنه ته بیا څه شي ته په پوه شي مطلب دا چې ستا په نور ځکه کې سوچ مو چې دام دې ته فوکس کا نو دغه شانتي دلته مو څه چل کو دا ریډیشن څومره جدا دی یو پوینټ ته فوکس کو نو اول ګوره مو سرفیس ونه سرفیس تم چې فوکس کاوه نو دومره دغه کنسنټریشن نه کېدو چې کله هم لاین ته کاوه نو کنسنټریشن سیوا شو اوس چې کله بیخي یو پوینټ ته پکې ته دا ټول ریډیشن وکړې تاسو به کنسنټریشن definitely سیوا کیږي. So let's suppose this the small a very easy example, and this is your numerical question, that suppose a theoretical storage device which contain a fluid R11B, this is a specific type of fluid, having variable specific heat capacity. इसका जो स्पेसिफिक हीट है वो वेरिएबल है, क्यों वेरिएबल है, इट डिपेंड ऑन टी। जब टेम्परेचर ज़्यादा होगा तो इसकी हीट स्टोरिंग कैपेसिटी ज़्यादा होगी, जब अगर इसके टेम्परेचर कम होगा तो इसकी हीट कैपेसिटी कम होगा। So it depends on 0.05 T. This T mean temperature plus zero point 0.2 kJ per kg dot K. This is the unit of specific heat capacity, where T is the absolute scale. Absolute scale mean Kelvin scale. सो कहने का मतलब ये है कि अगर आपके साथ कोई न्यूमेरिकल्स हो, इसमें आपके साथ सेंटीग्रेड में क्वेश्चन गिवन हो तो आप इसको कन्वर्ट करें किस चीज़ में, Kelvin scale. Determine the energy stored. In this device, when the temperature rise from 20 degree into 50 degree centigrade per unit time, अगर टेम्परेचर 20 डिग्री सेंटीग्रेड से 50 डिग्री सेंटीग्रेड तक पहुंच जाए यूनिट टाइम में, तब क्या करी, इसमें कितना एनर्जी स्टोर होगा इस फ्लूइड में, जब इसकी स्पेसिफिक हीट कैपेसिटी इतनी है, आप इसको क्या करें, फाइंड करें। सो सबसे पहले आप क्या करें, इसको एब्सोल्यूट में कन्वर्ट करें। सो टी आई मीन इनवर्ड फ्लो टेम्परेचर, सो इनवर्ड 20 था, और this is the formula for conversion from centigrade to Kelvin, that temperature in Kelvin is equal to temperature in centigrade plus 273. So it means 20 plus 273 means 293 Kelvin, and this is the temperature of out from the riser tube, mean that 50 plus 273, so this means 323. Now you know that we study the equation here, that the useful heat equation is mcp t, but in this case this t is varies from some value. So when this is vary, so you can convert this into integrations. For example, m is constant, integral from initial value to final value, and this is deta. Deta mean temperature is variable. This equation and the above equation is same. This equation and this equation is same, T naught minus Ti. But when the specific heat capacitance is does not depend on temperature, so then you can use T naught minus Ti. And if it depends, so you can write this equation in the integration form. M Cp integral from Ti minus T naught deta. We can prove this equation. For example, if Cp is constant, if Cp is constant, mean that M and Cp is constant, so it will be come out from the integration, and this is Ti, and this is T naught, and this is deta, d capital T, and here is 1. And you know that M, this is the Cv, and what is the integration of 1? This is capital T, and take the upper and lower interval. So write them. So M is into Cp, write upper limit. So T की जगह आप T naught लिख ली, and this is Ti, and this is your the required equation. So this is the integral form and this is the difference form. So here we will use this equation because the Cp depend on the temperature. If this is not depend, you can use only this. So first of all, you will find the Ti in absolute scale and T naught in absolute scale. Then write the equation M from T minus Ti to minus Ti to Ti to T naught Cp dt. Now write the equation is this is unit time. So unit time mean that M is equal to 1 integration from Ti mean 293 to, let's start this in the whiteboard. The question is that solution the Ti is 392. It's 392, and T naught is 293. This is 293, and this is 293, and this is 323, and this was 20 degrees C, and this was the 50 degrees C. But we will not use this quantity, we will use the absolute scale. And what is meant by the absolute scale? By the absolute scale, we mean that in Kelvin. So how we will convert into Kelvin? So temperature in Kelvin is equal to temperature in Celsius plus 273 plus 273. So it means that when you add 20 to 273, it will 293. And you will add 50 to 273 mean 320. Now the equation is the useful heat will be m is equal to 1 in the integration from 293 to 3 to 3. And what is the specific heat capacity? 0.05 T plus 0.2 plus 0.2 and theta, the temperature. So you may know the integration rules that 0.25 is constant, but what is the integration of T? So it will be T square by 2, T square by 2. And this is the generalized formula that integration of the Tn dt is t to the power n plus 1 divided by n plus 1. It means that if this is t square, if this is t square, so square को एक ज़्यादा कर दी. So cube divided by cube. This is square and this is now square because this is 0.05 t to 0.05 t. 0.05 t की integration क्या होगा? t square divided by 2. If this is t square, so t cube divided by 3. इसको एक ज़्यादा कर. If this is t cube, so t4 divided by 4 and plus 0.02. और कांस्टेंट का इंटीग्रेशन क्या होते हैं? जिसके साथ कैपिटल टी लगता है, कैपिटल टी. एंड राइट द अपर एंड लोअर लिमिट. सो 3 to 3 and 293. This is the upper and lower limit. Now write 0.05 0.05 and t की जगह आप लिख ली upper limit 323 square divided by 2 minus lower. ये आपके साथ इंटीग्रेशन का अपर लोअर लिमिट माइनस लोअर लिमिट क्या थे? 293. ये शायद आपने मैथमेटिक्स में पढ़ा होगा. डिवाइड बाई 2 प्लस 0.2 एंड व्हाट इज टी? टी की जगह आप अपर लिमिट 323 माइनस 293 ये लिख. When you solve this with a calculator, you will give the answer. You will get the answer 468 kilojoule. This is the equation. So let's start. So similarly, when we apply the 293 and this, so this is the 0.05 and it will become t square by 2 minus 0.0 t 323 and 293. इसको upper lower लिख ली. 0.052 upper minus lower. मैंने उधर इस तरह लिख रहा है, इस तरह भी लिख सकते हैं. प्लस 0.2 अपर माइनस लोअर. इसको अगर आप सिंप्लीफाई करें यू विल गेट दिस आंसर.
सर जी
जी जी
पदे के चदा कम सा दा यूनिट टाइम सर